Alright, so next we're going to look at exception to the octet rule. So not all elements will obey the octet rule where your element has 8 electrons around it. Let's say 4 bonds atau X 1, 2, 3 and memang 8 electrons lah, octet rule. So some of the elements they are exempted, dikecualikan because of 3 conditions where the number of valence electrons does not equal to 8. Bila dia less than 8, which is called incomplete octet, expanded octet, that means more than 8, and odd number electrons, that means like having 3, 5 and 7 or any other odd numbers lah, the numbers of electrons. So let's look at the first one, which is incomplete octet. So incomplete octet occurs when the central atom has less than 8 electrons. So maksudnya the number of electrons is not equals to 8, but it is less than 8. Okay. So elements that can form incomplete octet, they are boron, beryllium and aluminium. Okay. So a way for you to remember, okay, it is bebal, okay, beryllium, boron and aluminium. So these 3 elements, okay, they can have less than 8 electrons around them. Okay, so they are actually metals, but these atoms, they can form covalent bonds, covalent compounds with non-metal. Okay, walaupun dia orang metal, selalunya metal kita expect dia akan form ionic bonds lah, dia akan donate electrons. But it is not the case for bebal ni, okay, boron, beryllium and aluminium. Why is that so? Because their ions have a smaller size and higher charge. Okay, that means that dia sangat kecil and dia macam it has a high charge density. That means it is very positive. Okay, dia sangat positive. That means that they are able to attract the electrons of the anions strongly towards themselves, resulting in sharing of bonding electrons. Okay, so instead of accepting, dia akan share. Alright. Okay, so let's look at the example for incomplete octet. You are told to draw the Lewis structure for the following compounds and then choose the most possible Lewis structures for them and then explain why. Okay, so if we look at beryllium chloride, okay, BeCl2, okay, you can have 2 possible structures, but now we want to choose which one is the most plausible Lewis structures. So in order to do that, we are going to count the formal charge for this element. Alright, so yang atas tu, okay, where you have double bonds around beryllium, okay, if we count the formal charge, beryllium is in group 2, so 2 minus 4 will be minus 2, Cl will be 7 minus 1, 2, 3, 4, 5, 6, 7 minus 6 is plus 1, and this one is also plus 1 sebab dia ada double bond juga. Okay, so that is the formal charge for the first Lewis structure. Okay, if you look here, okay, beryllium is an electropositive element. Okay, but right here, if we octet beryllium, where you have 1, 2, 3, 4, 5, 6, 7, 8 electrons for beryllium, okay, double bond tu, dia punya formal charge is minus 2. Padahal it is an electropositive element. So that is not good. Okay, so electropositive element patutnya you will have positive charge atau paling bagus 0 formal charge. Okay, but that is not the case when you octet beryllium atom here. Okay, so another structure that we have is where our beryllium has 2 bonds around it. So that means that 2 minus 2 is 0. 7 minus 7 is 0. 7 minus 7 is 0. So, in this structure here, okay, lagi satu benda, chlorine ni electronegative atom, but it has a +1 formal charge. So, that is also not appropriate lah untuk electronegative atom. It should have negative formal charge atau 0, okay. So, if you look here, our beryllium is not octet. Okay, it is not octet. It only has 1, 2, 3, 4 electrons. Okay, sharing 2. But the formal charge, okay, for all your atoms in this Lewis structure is 0. So, this shows that beryllium, it can form incomplete octet. Okay, dia tak cukup pun 8 elektron, tapi dia okay je because the formal charge is all 0 for this Lewis structure. Okay, so this is the sentence that you will use to explain the most plausible Lewis structure that you've chosen. Okay, so you have to tell, okay, bila beryllium octet, the formal charge is -2, and then beryllium is an electropositive element. So, tak patutlah dia punya formal charge -2. When beryllium is not octet, the formal charge of all atoms are 0. So, this is the most plausible Lewis structure. Okay? So, plausible Lewis structure need to fulfill the appropriate formal charge of every atom. Thus, beryllium will form incomplete octet. Okay? So, use that sentence as well. So, you can use this sentence and the sentence I said just now for BF3 and AlBr3. You will find that these compounds, these elements, boron and aluminium, will also form incomplete octet. Dia tak cukup pun 8 elektron. So awak kena tunjuk lah, okay, bila awak octetkan awak punya elemen dengan bila awak tak octet, okay, awak form incomplete octet for this question. Next, we have expanded octet. So, expanded octet pula maksudnya dia akan mengembang lah. That means you will have more than 8 electrons for your central atom. Okay, what are the elements that will form expanded octet? They are elements of period 3 or higher. Why is that so? Because in period 3, you can have 3d orbitals. So, your valence shell, okay, you can expand it because you have empty d orbitals. Boleh isi lagi electron up to 10 electrons. So, the elements that can form expanded octet are phosphorus, sulfur, chlorine, iodine, selenium, okay. Anyone who is in period 3 or higher lah, okay. So, if you draw the Lewis structure, okay, for PCl5, it will look like this. You can see that your phosphorus, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. That is more than 8 electrons. So, dia form expanded octet. So, SF6 pun, you will have 6 bonds around your sulfur. Okay, that's more than 8 electrons. Finally, we have odd number electrons. Okay, terang-teranglah daripada nama dia. It is where your central atom may contain an odd number of valence electrons, 3, 5, 7. So, usually it is just nitrogen lah that will form, that will have odd number of electrons ni. Contohnya, if you draw the Lewis structure for nitric oxide, NO, you will find that your nitrogen has 1, 2, 3, 4, 5, 6 electrons around itself. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is an odd number electron lah for nitrogen here. Okay, finally, for 4.1, we have resonance. Okay, now that kita dah pass all that formal charge semua tu, now we are going to get to know resonance structures. So, resonance structures are two or more plausible Lewis structures for a molecule or ion whereby it cannot be represented accurately by only one Lewis structure. Maksudnya, contohnya untuk molecule compound macam ozone, okay, you can have more than one plausible Lewis structures. So kalau awak lukis, contohnya if you only show this one, okay, so this is not the accurate representation for ozone molecule. Your ozone molecule can also exist this way, where your double bond is on your left, ini on your right. So these structures, okay, they have the same relative placement of atoms. Maksudnya kedudukan atom awak sama saja. O, 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 O. Contohnya S, C, N, S, C, N. Tapi beza dia, awak punya distribution of valence electrons. That means that awak punya lone pair and bonding pairs punya kedudukan berbeza. So, cara senang untuk tengok, it is basically your double bond lah. Double bond awak duduk mana? Okay, between which atoms? Alright. So, each of the structure, it is called a resonance structure. So, if we have these two structures, it means that this structure is resonance to this structure. Okay. So, it will be represented with a double-headed arrow, these resonance structures. Okay, maksudnya they resonance to each other. Alright, so let's look at the example NO3-. Okay, so if you draw your molecule for NO3-, okay, you will be able to gerak-gerakkan the double bonds. So if I show you here, I'm just gonna show you dia punya siap dah resonance structure. Lewis structure. Okay, so copy this, paste. You will have 3 resonance structures for this one. Okay, so beza dia is the way you arrange your double bond lah. Okay, kamu saya buat tu. Okay, so let's say, okay, for the first one, saya guna the lone pair here to put here, so my double bond is right here. So for the second one pula, let's say saya guna this lone pair to have my double bond here. So maksudnya saya tak ada lah satu lone pair kat sini. So yang ni ada, yang ni ada. Okay, so ini, lepas tu saya gerakkan lagi saya punya double bond. Okay, I use this lone pair. So meaning I don't have it here, and I will put double bond here and single bonds here. So these are the 3 resonance structures that I have for NO3-. So don't forget to show your minus charge for your compound, for your polyatomic ion. Okay, kalau tak salah. Okay, so macam ni je lah awak draw your resonance structures. Okay, that means that you have to show the correct Lewis structure and then just gerak-gerakkan je double bond dia. Okay, tapi bukannya awak gerak suka hati awak. Kena make sure lah awak punya oksigen tu cukup octet. Okay, dia ada 8 elektron. So here pun jangan terlebih elektron pula. Kalau letak 2 lagi elektron kat sini, salah lah. Alright, so that's all for 4.1. Thank you.